The Tesla is a unit of measurement of the strength of the magnetic field. It is a derived unit of the International System of Units, the modern form of the metric system. 1 Tesla is equal to 1 Weber per square meter. The unit was announced during the General Conference on Weights and Measures in 1960 and is named in honor of Nikola Tesla. The strongest fields encountered from permanent magnets are from Hellbach spheres, which can be over 4.5 T. The strongest field trapped in a laboratory superconductor as of July 2014 is 17.6 T. The record magnetic field has been produced by scientists at the Los Alamos National Laboratory campus of the National High Magnetic Field Laboratory. The world's first 100 Tesla non-destructive magnetic field. Definition: a particle carrying a charge of 1 coulomb and passing through a magnetic field of 1 Tesla at a speed of 1 meter per second, perpendicular to said field, experiences a force with magnitude 1 Newton, according to the Lorentz force law. As an SI-derived unit, the Tesla can also be expressed as units used. R equals ampere, C equals coulomb, kilogram equals kilogram, M equals meter, N equals Newton, S equals second, H equals Henry, T equals Tesla, V equals volt, J equals joule, WB equals Weber. Electric versus magnetic field. In the production of the Lorentz force, the difference between these types of field is that a force from a magnetic field on a charged particle is generally due to the charged particle's movement, while the force imparted by an electric field on a charged particle is not due to the charged particle's movement. This may be appreciated by looking at the units for each. The unit of electric field in the MKS system of units is newtons per coulomb, N.C., while the magnetic field can be written as N. The dividing factor between the two types of field is meters second, which is velocity. This relationship immediately highlights the fact that whether a static electromagnetic field is seen as purely magnetic, or purely electric, or some combination of these, is dependent upon one's reference frame. In ferromagnets, the movement creating the magnetic field is the electron spin. In a current-carrying wire, the movement is due to electrons moving through the wire. Conversions: 1 Tesla is equivalent to 10,000 G, used in the CGS system. Thus, 10 kg equals 1 T, and 1 G equals 10⁻4 T. 1 billion gamma, used in geophysics. Thus, 1 gamma equals 1 NT. 42.6 MHz of the 1H nucleus frequency, in NMR. Thus, the magnetic field associated with NMR at 1 GHz is 23.5 T. 1 Tesla is equal to 1 versus per square meter. This can be shown by starting with the speed of light in vacuum, c equals -1/2, and inserting the SI values and units for c, the vacuum permittivity, and the vacuum permeability. Cancellation of numbers and units then produces this relation. For those concerned with low-frequency electromagnetic radiation in the home, the following conversions are needed most. 1000 nt equals 1 micro T equals 10 mg 1 million micro T equals 1 T. For the relation to the units of the magnetizing field, see the article on permeability. Examples: 31.869 micro T, strength of Earth's magnetic field at 0 degrees latitude, 0 degrees longitude. 5 Mount, the strength of a typical refrigerator magnet. 0.3 T, the strength of solar sunspots. 1.25 T, magnetic flux density at the surface of a neodymium magnet. 1 T to 2.4 T, coil gap of a typical loudspeaker magnet. 1.5 T to 3 T, strength of medical magnetic resonance imaging systems in practice, experimentally up to 17 T. 4 T, strength of the superconducting magnet built around the CMS detector at CERN. 8 T, the strength of LHC magnets. 11.75 T, the strength of INUMAC magnets, largest MRI scanner. 13 T, strength of the superconducting ITER magnet system. 16 T. Magnetic field strength required to levitate a frog according to the 2000 Ig Nobel Prize in Physics. 17.6 T. Strongest field trapped in superconductor in lab as of July 2014. 10 to 20 T. Maximum field strengths of superconducting electromagnets at cryogenic temperatures. 33.8 T. The current world record for superconducting electromagnets. 45 T. The current world record for continuous field magnets. 108.1011 T. Magnetic strength of the average magnetar.